Good afternoon and welcome to your science review with Mr. Blades. Today we're going over the projectile motion lecture. Let's get started. In vector addition, the sum of two vectors is called the resultant. We add our vectors head to tail, which means that the pointy end of the last one is where we connect the tail end of the next one. Then we use Pythagorean theorem to find the length of our resultant vector. We are now analyzing motion in two coordinate system. We have x and y. We will not discuss z in this course. Some key words: projectile, trajectory, and component. Projectile refers to any object in free fall, which means that regardless of its motion, it is only under the force of gravity. And under this definition, a bullet, after it's left the gun, would qualify as a projectile, because it is flying through the air but only being pulled down by gravity, whereas, say, a plane would not be considered a projectile because it's being carried through the air by its engines. Trajectory is the curve that describes the motion of a body in space. And lastly, the component refers to the x and y parts of the motion of the object. Because they are perpendicular, horizontal and vertical components are independent, which means that the acceleration of the object towards the ground because of gravity does not affect its horizontal motion. The horizontal component of the velocity is constant because there is no such thing as sideways gravity. Take a look at this picture. When we fire a cannon, the distance between each cannonball, which represents a uniform unit of time, is equal, whereas the vertical distance between each part of time grows according to Galileo's law of falling bodies. Now, if we combine the motion in x and the motion in y together, we get the curved path, which happens to be a parabola, and this describes the motion of an object in space under free fall. Take a look at this picture. If two people of different weights jumped off this same platform, which one would fall first? They would both actually hit the ground at the exact same time. And we can see from this picture that this person jumping off the high dive does in fact follow a parabolic pathway like we would expect. If we were to drop a bullet at the same time we were to fire a gun, which one would hit the ground first? It actually turns out that they would hit the ground at the same time and with the same vertical speed, and that's because they both have the same vertical acceleration. We can tell from the picture that two objects, one with some horizontal velocity and one with zero horizontal velocity, do in fact fall at the same rate. Galileo's law of falling bodies, as we discussed last unit, says that any object in free fall accelerates towards the ground with the same acceleration, regardless of mass. And that fall is proportional to the square of time, which means it increases by odd integers. Take a look at the video included. You can see that an object dropped from a plane would fall according to the same parabolic trajectory as we would expect. The vectors off the little red ball show the relative velocities of each direction. We can see that the x vector does not change and is in fact the same as the plane as it goes, but the vertical vector starts off at 0 and grows as the object falls. If you're in one of my classes that deals with angle, this slide is for you. Now, if we're trying to figure out greatest height, it would make sense that we would throw it straight up. And in this case, it is true. Greatest height is at a vertical or 90-degree launch angle, whereas the greatest distance, we would actually be looking for the greatest amount of time in the air while also moving forward. And that happens to be at 45 degrees. Now, if we throw an object at an angle, at the very top of its motion, its vertical velocity will be 0, because this is where it stops going up and turns around and begins to come back down. However, this does not affect its horizontal velocity, which is constant. And then at that moment, the overall velocity is entirely horizontal. This mirrors what would happen if we were to throw something horizontally off of a high cliff, whereas its initial vertical velocity would be 0 and its horizontal velocity would be constant. Same deal. Now, some key words and phrases on how to read and accurately respond to word problems on my quizzes. Please take a look at this table, pause it if you need to, and write these down. Being able to answer my questions correctly does somewhat hinge on your ability to interpret the questions. And then lastly, please memorize this. The acceleration and velocity and time, all the units will help you understand what we are asking for and what givens in the problem are actually telling you. Lastly, please take a look at these equation summary. If we start with the original displacement equation from the last unit, delta x equals v delta t plus 1/2 a delta t squared, and adapt it to the situations as we know them from our problems, we can see that most often our vertical motion is reduced to delta y is equal to 1/2 a delta t squared, and our horizontal motion is delta x equals Vx, or velocity in the x direction, multiplied by time. I hope this was helpful, and I'll see you in class.